seconds.
Yeah, thank Viridiana. So I'll start sharing my screen. Okay, can you see my screen?
Yes.
Okay. Yeah. I'll just minimize this. Just bear with me. Okay. So thanks. Thank you for that introduction, Viridiana. So I will, before I start, I would like to, and thank you for the invitation to present today. Very happy to be here. So before I get started, I just would like you to take a moment to look at the picture you see on the screen, because that really sets the context to what I'm going to talk about. As you can see, this is probably some children in a refugee camp somewhere in the Middle East or North Africa. And what they're doing is they're exchanging vouchers for food. And you can see from the expressions of their faces, these children are hungry. So food is very important. So they are in a humanitarian situation. They have been affected by some disaster, and they're looking for food. So that really puts the context to my talk. So in the humanitarian context, we often hear about people having to have water and shelter, but food is really essential for survival and social well-being, as we know. And what I'm going to talk about is to get the link between food engineering and the humanitarian situation. And I hope, now this talk is going to be a bit different to the normal webinars under this series. I'm not going to talk about mathematical modeling or advanced food engineering. It'll be pretty basic, but I hope at the end of this talk, you will get some awareness of the role food engineers can play in a humanitarian situation. So I'll give a bit more context as to why this area is important, and then I'll go on to talk about the role of food science, technology, and engineering in a bit more detail. I'll say a few words about humanitarian food systems, and then I will talk about this group, Humanitarian Food Science and Technology group, or we abbreviate it as HFST. It's a global working group that I will talk about later. Then I will briefly mention a case study we are doing in the Congo, and I will finish with a question to have us. I hope it will lead into a discussion whether we can define a discipline called humanitarian food engineering. So as we all know, every day when we watch our TV screens, we always hear some problem somewhere in the world. Either these problems are natural, like earthquakes and floods, very often caused by climate change, which we hear a lot about. Some countries, these are ongoing, they are constantly in drought or constantly subject to floods, like in North Africa, the sub-Saharan Africa, or some Asian countries, and some are man-made. So as you know, somewhere in the world, there's always some political unrest, which leads to conflict, which can lead to wars, as what we see these days with the war in Ukraine is one example, but these things have been happening for many, many years somewhere in the world all the time. And of course, 2 years ago, we had the COVID pandemic, which is still going on, that also had a huge impact among many people. Now, whenever these, what we call external shocks occur, there's an emergency. This can lead to food insecurity, hunger, and malnutrition. And the impact, the humanitarian impact is there can be social and economic impacts. When there's a flood or a drought, the crops there won't be any local crops, which means people won't have food. So this can lead to food insecurity, which will result in hunger and malnutrition and even mortalities. And in some countries, particularly in developing countries, the impact can be long lasting. And you have seen the statistics before, so the problem is quite severe. And very often we see images in Africa or Asia, but recently we have seen these images even in developed countries, like what's happening in Europe, not only because of the war in Ukraine, but there have been Syrian refugees went to Europe. So there are humanitarian issues in developed countries as well. So very briefly about malnutrition. So when people are food insecure, that can lead to undernutrition or obesity. Now, even in developing countries, you can have obesity because people can eat too much of the wrong food, and that can cause long-term problems too. So if you look at the impact of malnutrition on a particular community, so let's imagine that because of an external event like a flood or drought or war, a particular country or a particular community became food insecure. And if it is long lasting, it can lead to long-term malnutrition. That can lead to physical and mental impairment. That can lead to inability to study and to work. So if people don't study, they don't have the proper skills. And if they're not physically fit, they can't work, which means there will be a loss of income that will lead to poverty. And if they are poor, even if food is available, they probably won't be able to afford to buy the food. And this whole cycle is repeated. And they will never be able to get out of it. So it is very important. The point I would like to stress is if there is a humanitarian situation that could lead to food insecurity, it's very important to address the problem quickly before, and provide them with the right food before malnutrition sets in. So, so when we talk about addressing the problem, we talk not only about the quantity of food, but the quality of the food too. And the quality of the food has to target the particular demographic. So for example, infants and children will need a particular type of food. Adults will need another type of food. So we have to be mindful about it. So as I explained, the humanitarian situation is quite bad. It's very acute in many parts of the world. And we are talking about millions of people who have been affected. So the question is, how can we get the right quantity of food in the right quality at the right time to the right place to the right people? How does all this work? So the answer is we already have systems to do this. And the main UN agency who leads this activity is the World Food Programme, or WFP for short. And if you're interested how it's done, I encourage you to, I don't have time to show this video, but there are a lot of videos and information on their website. So if you go, please have a look, because it's very interesting how that's done. So very briefly about WFP, as I mentioned, it's the main agency responsible for procurement, transport, and logistics. Their headquarters is in Rome, but they have operating offices in all over the world, in every continent, but they don't work alone. They work with the local governments and NGOs. The scale is huge. They feed millions of people every year. And they're very good in procurement, logistics, and providing the food very quickly. However, they don't, WFP don't manufacture any foods. So they source food from hundreds of suppliers located all over the world. And that itself is quite a challenge, because the quality has to be maintained. So when a disaster happens, they put in place put into place a process very quickly. So within a few, within a day or 2 days, various systems are set up. They get people on the ground, set up communication systems, and then the appropriate food is sourced and distributed, but they ensure that malnutrition doesn't set in once the emergency is over. So they have to give, together with local organizations, they have to continue to give the right support. So when we talk about emergency, we talk about 3 different phases. The first one is what happens before the emergency occurs. That is what we call the preparation phase. Then what happens during the emergency. That is, so if there's an earthquake somewhere, immediately you have to respond. So that's called the response phase. And then you have the rehabilitation, because very often the crops would be damaged, would be lost, infrastructure would be broken, people may have to be re-educated. So in terms of our role as food engineers, we don't get too involved in the response phase, but this is more to do with logistics. You can't process and prepare food when there's an emergency, but what we can do is to prepare for this. Now, FAO has a system whereby they can predict where problems are likely to occur based on historical information and climates and political instability and so on. So they color code this. Every country has a color code. So if it's food secure, it's green. If there's a famine because of ongoing drought, for example, it's this color. So those countries where they can anticipate a problem, what you have to do is to prepare the food before the emergency occurs. And food engineers can play a role because we can process foods, we can extend the shelf life, we can make sure it is stored properly under those conditions. So when the emergency occurs, the product is available. Similarly, after the emergency, we can take an active role in developing skills locally. And I will talk about that later, and ensuring the people who are affected are more resilient for problems that might happen later. So if you now look at the role of food science and technology in a bit more detail, so all the areas that we are familiar with, from formulation products to developing shelf life, are relevant for emergency foods too. But we have to be mindful because the situation can be different. So for example, if you are living in a refugee camp, you may not have access to clean water. There may not be cooking utensils. So giving raw materials may not be very relevant. You would have to give them ready-to-eat foods. But, and sometimes the only meal they may get may be a food bar. So the portion control and the nutritional compositions are very important. Packaging is important, not only to protect the food, but it has to be robust, because you would have seen on TV, sometimes this food is dropped from the air if the agencies can't get to the places because infrastructure is lost. And also, even if it's a refugee or an affected person, you still have to look at the consumer as a consumer and ensure the sensory requirements and the cultural requirements are addressed. So let's now focus a bit more about the role that engineers can play. And I'll refer to this as I go along. I think we really have to encourage people to use local raw materials than rely on imported foods. And our main contribution is in processing technologies. But here again, we use this term called appropriate technology, which means the technologies we use to process foods have to be appropriate to the situation. So we are probably talking about setting up a food processing facility in a country where the skills are not very advanced, where power may not be available. So we have to, there's no point in installing a highly automated plant if there's no one there to operate it. So, and also the scale can be a village scale, or it could be in a local production, or it could be central, where products can be centrally produced and distributed. Quality control, I'll come to this in a minute. And these days we talk a lot about sustainable food processing, and this applies to a humanitarian context too, because we must make sure whatever we do has minimum impact on the environmental footprint in terms of water, energy, and packaging. And of course, minimizing cost is something we do all the time, but in a humanitarian context where a lot of the people in poorer countries probably can't afford to buy processed foods anyway. So we have to be even more mindful about the cost. So I'll give you a very quick overview of the typical products that are used right now in emergencies by these various agencies I referred to. Now, you would have come across this before. This is called the general food basket. Typically, it's a combination of rice, salt, sugar, some grain, some oil, and this is what's called fortified blended foods, and I will describe that later in a bit more detail. This gives you a feel for what a refugee camp might look like. Now, I want to show this because you can see these people don't have any energy or cooking utensils. So giving this food basket to them is not very relevant because they won't be able to cook the foods. So they have to be given ready-to-eat foods. So I'll show you some foods. So the food that can be given to them could be uncooked, fortified with vitamins, or it can be something like this. Now, this is for infants. This is pre-cooked. So all the mother has to do is to mix this with water, and it can be fed. This is another common product that's distributed. This is pre-cooked. So this can be combined with water to make a porridge or gruel. And these are called pre-cooked fortified blended flours. And this can be corn soy blend, wheat soy blend, or rice soy blend, commonly used in aid. Now, the next stage of this is where you can formulate it in such a way so that it's targeted to a particular group, from infants from 6 months to 5-year-old children to pregnant mothers. This is another popular thing. These are called compact bars. It's pre-cooked, so it can be eaten as a bar, or it can be granulated, mixed with water, and made into a porridge. And this shows the composition. And you can see, depending on the number of bars you eat, you can feed, you can give the daily nutritional intake for 6-month-old infant or to adult. Another popular product is what's called a high energy biscuit. Similar composite nutritional density to the energy bar. This is now we are going to the therapeutic products, where this refers to severe acute malnutrition. So these are specifically formulated to feed infants and children who are about to die. So if they are not given, you are moving from food into therapeutics. If they don't get this nutritious products, they will have severe problems. This is another popular product. This group is called Lipid based nutritional supplements, or LSNs. Basically, it's like a peanut butter product. The base is peanut butter, but it is mixed with more oil, sugar, vitamin mix, milk powder, and it's ready to eat, and it can be distributed in sachets, but it can, of course, cause a big environmental problem with the packaging. And that product could be made, as you can see here, in a domestic kitchen. All you need is some kind of a mixer and a size reducing equipment, or it can go all the way to semi-industrial products. And in some countries, the traditional use of peanuts have been replaced by almonds or chickpeas. So let's now move into the processing of this product. So this is more closer to our interests. So if we look at this flow diagram, we begin with cereals, typically wheat, corn, or rice, and then we would have pulses to enrich the nutritional profile. And you can see there are 4 different streams showing 4 different methods of processing. So the first one, you have a dry milling process. Then you make a wet slurry, you drum dry, you go through a size reduction process, you mix it with a vitamin mineral supplement, and then you package. And then that's pre-cooked, so it's ready to eat. The second one, you make a dough, and then you can bake it, and you go through the same process. The third one is a dry roasting process. So here the starch is not fully cooked or fully gelatinized, therefore it's not digestible. So this has to be cooked before consumption. And the fourth method is the one where I want to spend a bit more time because there's a lot of interesting science here. And this is using a cooker extruder. So here what you do is you feed the dry blend, and with enough moisture, the product is fully cooked. So it can be consumed without cooking again. And you can mix vitamins and minerals after the cooking if they are heat sensitive. So let's dig into this process a bit more, because as I mentioned, there's a lot of interesting science, and this is a good example of food engineering. So some of you who are familiar with extrusion cooking and cereal chemistry would know we, rather than using the word gelatinization of starch in an extrusion process, the preferred term is degree of cook. And this term was coined up by Robin Guy many years ago in the UK. He is a cereal chemist who worked on extrusion. And the reason is, in extrusion, as you know, we have very high shear, and that's how extrusion is cooking is different to normal cooking. So what happens, as this diagram indicates, the native crystalline granules of starch in the initial stage will hydrate, and then they will gelatinize with heat. And then the difference is, because of the high shear, these gelatinized granules break down into little fragments, and there's an element of dextrinization. The starch is degraded. So if you look at what happens to the viscosity, if you take that and reconstitute and measure the viscosity, what happens is that as you cook, as the degree of cooking increases, the viscosity, this is a consistency index, will reach a peak because of gelatinization. But as the shear forces increase, because of the breakdown of the gelatinized starch granules, the viscosity will actually decrease. So this decrease in viscosity has a very important benefit when you feed infants. So that is why extrusion cooking is so good. So I'll explain what happens through this diagram. So when you, if you can imagine, you using a pre-cooked flour, you can reconstitute it into a porridge and you feed the infant. In that process, there are 2 constraints. The first one is the ingested volume that the infant can take, and that is determined by the volume of the stomach, and that is 170 milliliters. The second thing, that the limiting factor, is the viscosity of the gruel after rehydration. And that is because if the viscosity is too high, the infant or the child can't swallow the product. So, and the maximum viscosity should be 1.6 Pascal seconds. and our objective to get the right nutritional, the energy density is we have to have 30 grams of dry material per 100 milliliters. So if you look at this curve, and if you look at this traditional cooking curve, this is the viscosity plotted against the amount of dry matter, you can see the maximum viscosity for swallowing is reached when you only add something like 13 dry matter, more than half of the required amount. But as we increase the thermomechanical energy of the cooking process, like in extrusion, you can see this red curve, which is the extruded product. You can add 30 grams of dry matter, which is what we are trying to do, but the viscosity is well under the limit. So the bottom line is this: you can get the right nutritional density in the right volume and the right viscosity, and that is why extrusion cooking is used to pre-cook blended flours. And I think that's a very good example of where you can manipulate the process to change the functionality of a product to address a target market, in this case, an infant. And so here we use a process to do the change. The other way to do this is to use enzymes, which is not the best option, and it can be expensive. Now you may wonder, you may think extrusion cooking is expensive process to use in a affected poorer country, but that's not the case, because this process can be done with a single screw extruder. Yes, twin screw extruders are sophisticated machines and they're expensive, but twin screw extruders are cheap, relatively cheap, and also you can get a very high throughput. You can produce at about 2 tons per hour. So the cost per unit in a single screw extruder is quite affordable. So another example, that is why extrusion cooking is often used in humanitarian situations, and is another example of some work done in South Africa. This was published soon after the food insecurity problems in Rwanda, soon after the COVID hit 2 years ago. Now, now I want to share with you another method of food processing. So you may ask, if we have a crisis somewhere in the world, and there's infrastructure has been damaged, but they have the local raw material. They can grow wheat, they can grow soy, they can grow rice. So they're looking for, the local community is looking for setting up a food processing facility, but they don't have the skills or the time to do it, because this has to be done quickly. So the answer is what's called containerized food production. This is also sometimes referred to as a factory in a box, which is what it is. As shown in this photo, a whole factory, food processing plant, can be set up in a container, and these containers can be air freighted and then loaded into a truck, taken to where it's needed, and they do connect the power and the water, and then you can very quickly have a processing facility. And this is an actual case study of such a factory that was set up in Afghanistan by WFP to make high energy biscuits. And you can see this is the inside of the factory. You have mixing machines and forming machines. And you can have several of these containers configured in different ways. So one can be a lab, one can be a processing, one can be storage, to do whatever you want. So if you're interested, please have a look at this video. And it shows exactly how it was done. So this processing facility was fabricated in Italy, air freighted to, I think it was air freighted to Pakistan, and then by land it was taken to Afghanistan. And the interesting thing is they use this facility not only to feed school children, but also they were able to sell the product and generate revenue and create employment and so on. A very good success story. Now, very briefly about quality control, whether humanitarian or, no, we are familiar with it, we take it for granted. But even in a humanitarian situation, both for legal and ethical reasons, it is important to get the quality right. I mentioned earlier with WFP, they source food from hundreds of suppliers. So the question is, how can they ensure, particularly when they feed children, where the nutritional profile has to be exactly correct, how can they ensure that both nutritionally and food safety-wise, the product meets the specification? So all these things, microbiological, chemical, nutritional needs have to be met. So three UN agencies, WFP, FAO, and WHO, WFP in logistics, FAO on raw materials, agricultural raw materials, and WHO in setting up protocols for nutritional requirements for infants and malnourished children. They work together and they have set up specifications and systems to ensure that these conditions are met by the suppliers, and they do audits and so on. If you're interested, I've given a couple of references. You can go into more detail. Now, very briefly about humanitarian food systems. So as you know, these days, we tend to use the word a food system rather than a food value chain or food supply chain, because the value addition happens from left to right, because traditionally we think about the raw material processing, which is the value addition, and then the consumer. But now we link it with the economy, with the society, with the environment. That is why we refer to this as a food system. Now, if you look at the humanitarian supply chain, we still start with some agricultural raw materials, and we have a consumer at the end. But the difference is we now focus more on local raw materials, and the processing is, the focus is not so much to make a profit by value addition and marketing, which is what tends to happen in the societies we are familiar with. In the humanitarian context, what's more important is the appropriateness of the technology, not high tech or market driven. And we had to make sure that local resources are used, and even energy, because they may not have access to electricity. And the product has to be simple and fit for purpose. And we still have to fulfill the consumer needs, particularly the nutritional needs. Now, if we look at a humanitarian food system, here we have, this is developed by my colleague Dominic Booney, which is in our publication that I refer to later. So the drivers are, we talk a lot about resilience, and we talk about this arrow is the shocks, what we call the external shocks. That can be earthquake, or it can be a pandemic. So this circle is the traditional value chain, but the outer circle, we have added these other dimensions like the regulatory issues, political issues, economic issues, as well as the technological and the social issues. So it covers a whole lot more than the horizontal value chain that I referred to earlier. So now I want to talk a little bit about this humanitarian food science and technology group. So from everything I mentioned so far, you can see that there are humanitarian issues all the time. And I hope you can now appreciate that food scientists, food technologists, food engineers can play a role in ensuring the correct foods are developed. However, going back to even before this, to about 2015, a group of us realized that the role of food science and technology is not recognized by the food science community, as well as the external stakeholders like UN agencies and governments and food suppliers. So we thought we should try and try and find out a bit more, first of all, what food scientists, technologists, and engineers could do, and how we can increase awareness. So 5 years ago, we organized a symposium followed by a workshop in Sydney, and we invited representatives from different countries and different stakeholders. We had a good session discussing all these issues, and we set up this group with the main objective of identifying our role, increasing awareness, and also to influence policymakers. So with that in mind, we defined food science and technology like this. So it's application of food science and technology to enhance food security, health, economic prosperity for global humanitarian purposes. So you can see the way we got the term food science and technology and humanitarian, but it also covers food security, it covers health, economic prosperity is the outcome, and it is global. And we included this definition in the paper that we published. Now, I should also point out, you will note here we don't use the word engineering. That is in a way a bit deliberate because we talked about it, but we felt if we put the word engineering, because as we know, a lot of people don't use the word engineer in the right context. They don't relate it with food. So whereas technology is used more widely. So the word technology includes engineering, it includes nutrition, and it includes microbiology. So I'm not going to go through this in detail. These were the recommendations we made, because these are all explained in more detail in our paper, and I'll give you the reference in a minute. But very briefly, we recommended that when there's a response to an emergency, rather than just reacting, we also to think about development. This is long-term. And also the beneficiaries should change their mindset rather than relying on aid. They should think about developing capability locally. So capable of processing their own food and making them more resilient, focus on local raw materials, appropriate technologies. And also we found a lot of the work that's happening in this area is all about increasing yield in agriculture, not so much post-harvest processing. So I think this integrated food system is important, which includes food processing and distribution. And increasing awareness that I referred to earlier. The private sector, we believe, should play a bigger role than what they're doing at the moment. There are many reasons why that's not so, some historical, some political, and there should be better public-private partnerships. Investment in innovation and training is important. And there's another important thing. I think it's very important. We have to attract early career scientists and students to learn about this field. And I'll come back to that later. So this is a publication that I referred to. So if you are interested, please, this is a good starting point, because when we started researching into this 2 years ago, or nearly 3 years ago, we found there was hardly any publications in this area. There were a lot of publications in humanitarian engineering because it is a well-established discipline, but the combining food with humanitarian engineering or food technology wasn't there. So that's what we did. Then we discussed how can we share this knowledge more broadly. So this is where we have to thank the Australian Institute of Food Science and Technology that Viridian referred to earlier. The CEO of this institute, Fiona Fleming, is a member of our group, so she's very supportive. So what we did is to use the AIFST website as a platform to share all the information that we have collected so far. So our internal report, our the various articles we wrote, our journal paper, and we keep adding into this. So if you want to find more information, a good point would be just do a Google search under Humanitarian Food Science and Technology, and you will find this page, and that will give you more information. Now, another thing we did, another one of our members in our group, Donna Rosa, she's based in the US, is actively involved with the international division of IFT, and she's done some very good work to get more young people involved. But and has set up a website in IFT's webpage as well. But just to let you know, IFT uses a different terminology because the focus is more on development. So we use Humanitarian Food Science and Technology. In IFT website, the word food science for relief and development is used. But really what we're doing is exactly the same. So don't be too confused with the terminology. Now, another thing we did was to increase awareness of the role of food science and technology in the Food System Summit that was held in New York last year. You may know that leading up to the summit, a lot of consultation took place with many stakeholders over 2 years. But we felt that the role of food science and technology was not addressed enough. This to do with sustainable food systems, which has a humanitarian dimension as well. So we did a couple of things. We wrote a paper making the point that there has to be more integration of food science and technology in sustainable food systems. And this paper was submitted to the Food System Summit Secretariat. In addition, we used change.org, and we made a call, and we wanted to make this issue more, get more people globally aware of this issue. And we had something like 700 endorsements from people in 70 countries. But then immediately after the summit, we thought we had to do something more tangible rather than just increasing awareness. So we made a commitment, and this is in the commitments registry of the Food System Summit. We made 3 commitments. First is continue to increase awareness of the role food science and technology could play in food systems. Second one, we felt that we should do more case studies, more practical works, and demonstrate the benefits through real studies. And the third one is in the area of education and training, getting the new generation set up. So here you can see our group has about 25 people from all the continents, covering the academia, the research sector, the ISFE, and some NGOs. There's an NGO in the Congo with whom we are working, which I will talk about. So at the moment, these are the projects we are working on, addressing malnutrition in Congo. We are about to start a new project with UNSW and WFP in Bangkok, based WFP, looking at school children's meals in Nepal and Sri Lanka, education and training. And we have held a few symposia already through ISFE and IFT, and this work will continue. So very briefly, I just wanted to get a feel for this project we are doing in the Congo. So many people there are malnourished, and one of our members is a pediatrician in the Congo. So he set up this NGO called Kesho Congo. You can do a Google search and get more information if you like. But what they're doing is a very admirable thing. They grow cowpeas locally, and which is very rich in protein. So what they're doing is, with some technical expertise, mainly from France, they are extracting the protein literally in a kitchen and incorporating it into a cookie and to a porridge and feeding the children and monitoring how the clinical benefits. So what we are doing is a group of us from Australia, France, Belgium, and our key partner in Congo are working together to see whether we can understand the science behind it and scale up the process. So these are the technical challenges, the optimizing the protein extraction process, optimizing the process itself to maximize the yield, scaling up from the kitchen to village scale and possibly semi-industrial, formulating the product to get the right nutritional properties and sensory properties, all the way to doing clinical studies and studying the economic impact. This is a flow diagram. Essentially, what you do is you extract the juice, then it's a heat coagulation process for the protein. The wet protein is pressed for dewatering, granulated and dried, and incorporated into a consumable product. Now, just to get you a feel, this is what actually happens in the kitchen. You can see the leaves are fed into this little juice extractor. This is a press for the wet curd to make it to dewater. This is the way the porridge is made, and this is the way the cookies are made. So we are trying to scale this process through a scientific understanding to a continuous process. Now, although this looks simple, if you dig deeper, if you look at each process, you can see there are many unit operations we are familiar with, from size reduction to separation technology to texturization to functional changes, and we have to select or develop equipment to do this in a continuous basis. So what are the benefits if the project is successful? You can see the impact is immense. We can address malnutrition. We can use locally grown crops, all the things I referred to earlier. You can create employment, empower women, be less resilient on age. And if successful, this technology could be transferred to other parts of Congo and indeed to other countries and utilize leaves as a source of protein to address food insecurity. So for food engineers, what are the learnings? Although it doesn't sound too complicated, we can still use the core principles of food engineering in this example, but we have to make it appropriate. We have to understand the local limitations. We have to use local skills, and we have to work in multidisciplinary teams, not only with nutritionists and clinicians, but also with social scientists, because the system is very different, and we have to go with a different mindset. So very briefly, the role of food science and technology and engineering, there are many challenges: formulation, product formulation, consumer requirements, designing the right package, making it sustainable, using appropriate technologies, using, and we can also learn from things like defense and space, who have similar problems, and training the future leaders and developing more partnerships with the private sector. So I want to finish with some thoughts on humanitarian food engineering. So the question is, with everything that I mentioned so far, do you think there is a discipline? Can we define a discipline called humanitarian engineering? Because it doesn't exist at the moment, at least as far as we know. Now, there is a discipline called humanitarian engineering, and there are many definitions, and there are many universities that teach humanitarian engineering, including Ohio State universities. Now, I've highlighted some words from two definitions. So we talk in humanitarian engineering about humanitarian aid purposes. We talk about disaster recovery. We talk about human welfare. But in my opinion, humanitarian engineering is very much about infrastructure. So if an earthquake destroys a certain community, these engineers will be involved in developing water purification plants or energy systems or housing or roads or bridges or whatever. Normally, so that's why they use traditional civil, mechanical, and electrical engineering. They don't normally talk about food. You can see the food is not mentioned anywhere in these definitions or in the curriculum of these courses. Likewise, when we talk about food engineering, we don't talk about humanitarian issues. So the question is, can we combine humanitarian engineering with food engineering and define a new discipline, which essentially would be a combination of food science and technology and chemical engineering, which is mainly food engineering, together with humanitarian engineering and social science. So the definition could be the application of food engineering to enhance food security and health for economic prosperity for humanitarian purposes. You will see this is exactly the definition we used before, but I replaced food science and technology with food engineering. So with that thought, if you believe that it is worthwhile training students in this area, the question is, how do we do it? Do we have it as a module in a food engineering course, or do we have it as a module in a humanitarian engineering course? Or do we have it as a module in a chemical engineering course or in a food science and technology course? So this is one example. This is in the University of New South Wales in Sydney. This course was launched last year in the School of Chemical Engineering in the food group. And this is, so what we are doing is offering students in food science and technology a minor in humanitarian science and technology in conjunction with the humanitarian engineering school. So that is something for you to think about. So I'll conclude by just summarizing the key points I made. The world is reaching many, many uncertainties, which leads to humanitarian situations. More work could be done than that's being done at the moment. We have to shift from relying on aid to being more self-sufficient. Food engineers can make a significant contribution to this area. We have to increase awareness of this area, both among food engineers, to think about this as a potential opportunity, but also among other stakeholders. And training in food, humanitarian food engineering should be considered, and earlier career scientists should consider food and humanitarian sector as a potential career option. If you want to get involved, please reach out to us. All these people I've indicated here in our group, humanitarian group, from different continents. So I've given all the contact details. Please reach out. And I will conclude by acknowledging all my colleagues, particularly Dominique Booney, because this area was all new to me a few years ago, and I have learned a lot, and I thank them. So with that, I'm sorry I went over time a little bit, my apologies, but I'll hand over to you, and I'm happy to answer questions and take part in the discussion. Thank you very much for your attention.
It's perfect. Thank you. Thank you so much for sharing your knowledge with us. It was a very, very interesting, different, but very interesting topic. So we'll start with the question and answer portion of this webinar. Dr. Torres, if you already have your hand up.
Yeah, I was thinking that if we're going to create this field, maybe we can change our vision from the disaster area, which will be it's a big problem, but it's also a smaller fraction of the problem. I mean, I'm thinking about what in the US we call food deserts. I mean, I live in a very wealthy community. I have wonderful food availability around me, wonderful supermarkets. But if you go to some neighborhoods, we call them food deserts because there is no available healthy food. And that creates a cycle that you mentioned before, right? That if you're eating unhealthy, you also are going to have physical and mental development challenges, and therefore you will be less trained, et cetera, et cetera. So and the problem with those food deserts, they're eating the food that the food industry is very good at doing, very low cost, but very low quality. Another example, as you mentioned, COVID, I was shocked during COVID to see that the food bank in my neighborhood had long lines, maybe 2-3 blocks of cars waiting to get food. So this food insecurity is not just a developing country issue, but it also exists When we look at the more population fractions in developing countries, that developed countries that have not that wealth, and therefore they have the same challenges that poor countries have. So
yeah,
if we
Jose,
can,
I fully agree with you. I didn't have time to go into it in more detail, but if you're interested, I must introduce you to my colleague Dominique Bouni, whom I mentioned, who is living in France, in Lille. And as we speak, he has a project going on, doing exactly what you referred to do with, because there are a lot of problems with refugees in certain parts of Europe. And next week, they're having a workshop between the University of Lille, University of Ghent, and the University of Kent in the UK to talk about exactly what you are referring to. And from, because I was looking to some of the slides earlier about that, there are about 15 million people, that's the figure that had been quoted, in developed countries, Europe and the US, who are going through the same problem. And you are absolutely right. We should not associate this problem with developing countries alone. And the problem is getting worse, like what's happening in Ukraine at the moment. With all this instability, because we live in a global world, isn't it? When there's a problem in Syria, what happened in Syria, all these refugees went to Germany and other countries and created a problem, humanitarian problem in those countries too, like what's happening in Poland right now. Yeah, agree with you, Jose. Thank you.
Thank you. Ricardo, please.
Well, thank you, first of all, for all your presentation. It was very interesting. My main question is in food containers. I had a quick Google search. I had two questions, but one of them was answered. But my main reason is waste control is manual. In the operators and engineers have to take care of all that. Well, I know how we have to take care, but manually control all the waste, because in these food containers and the situation of Yefte you talk about, I'm pretty sure the last thing we want is to let the waste damage all the soils, all the crops, all the resources of the air.
Yeah,
So,
yeah. I agree. I think the waste issues has to be part of the whole system, and that's where I think the training and the design has to be considered in such a way so that it's a circular system. Yeah, yeah. Good point. Yeah.
Thank you so much. I have a question, Jay. I was looking for the World Food Program. Mexico is not in the World Food Program, right?
No, but
Why? Because we need it.
Actually, it's interesting. You asked that, really, Diana. One of my our colleagues who was in our group, her name is Carla. She was based in Bangkok regional office. She about a year ago, she moved to your part of the world, to Panama. So World Food Program has a regional office in Panama that covers Central America and Latin America. So Mexico comes under Panama. So if you look under the Panama Regional Office, and if you are interested, by the way, I can introduce you to Carla. She's the food technologist, and she's a lovely person. She's very familiar with, she's one of the authors in our paper, by the way. Yeah, Carla Magia.
Okay.
Yeah. So feel free to contact her. If you search, you otherwise ask me, I can pass you her contact details.
Thank you. Dr. Torres.
And also, sorry, another, you may know our colleague Jose Reyes. I don't know if he's in this call. He's in our group, well-known food engineer. He's right now at the University of Georgia, but he's moving to Florida. He also has a lot of interest in Latin America and Central America to develop this type of work and in training. So it's another person you can reach.
Okay. Dr. Torres.
Okay, one question that I had about funding. Have you approached the Melinda and Bill Gates Foundation? Your type of work sounds very much about a project that they may be interested. Have you contacted them?
Yeah. I'm glad you raised the question of funding, Jose. So before I answer your question about Melinda and Bill Gates Foundation, I didn't have time to go into that. That project in Congo that I referred to at the moment is done all by volunteers. So we are doing some work with students both in France, Belgium, and Australia. And we are right now trying to get a bigger grant so that we can do all the things that I talked about, all those technical challenges, scaling up, developing the process. We need funds and we need more resources. So finding funds is not easy and it's very complicated. So with that in mind, with Belinda and Bill Gates Foundation, from my experience, because when I was at CSIRO about 5 years ago, we applied for a grant to develop an extruded product in Nigeria using cowpea, not leaves, but the grain. But the point I would like to make about that foundation is generally they're very active in Africa, but not so much in food. It's mainly to do with biotechnology. They have a big involvement in Kenya, in Nairobi, and as you know, in the medical area, reducing aid and improving hygiene and so on, but not so much in food. But about 5 years ago, they had a special call to develop a nutritious product for children. That's why we applied, but it is very, very competitive. Thousands of people applied and it's very selective. So the answer to your question is it's not easy to get and it is not readily available for food. It's more for medical purposes, in my opinion, yeah.
Okay,
If you have any thoughts, if anyone listening has any thoughts about how to get involved in this type of project and get more involved through resources or ideas for funding, please let us know, because it's a real project and there are many projects similar. School feeding that I refer to is another one, because in many countries, children, the only meal they get is through their schools. Now, when COVID struck, all the schools went into lockdown. So even that meal they did not get. So WFP are doing a lot of work in Asia and also in Latin America. Carla is working on this too, making sure the food is nutritious, looking at the supply chains, training people, making sure the food is safe. So there are a lot of good work is going on, but we need more people involved. So this work we are doing, planning to do in Nepal and Sri Lanka, we got a grant for travel only to send 7 students to do field work, to do practical work, to work with the local office of NGO and the government. But the problem is, because of COVID, they can't travel right now. So the whole project is on hold. And trying to do it remotely is not the same. They really have to go and get that hands-on experience. And WFP will give, if you make the right contacts, they will give these opportunities for students to get the experience.
With Dr. Welty, we have currently a special issue for ISFE, Innovation in Food Science and Emerging Technologies. And the topic of the issue is exactly food for emergency situations. Hopefully you will be able to accept an invitation to submit you and maybe some of your colleagues also a publication, because we've been struggling to get people interested in this topic. I thought it would be easy, an obvious need, and you're right, nobody cares.
No, that is exactly what we found when we wrote this publication, Jose. When we did a literature search, there was nothing published. And then we were struggling to find a publisher, because there were, as I said, there are a lot of publications in humanitarian engineering about logistics and supply chains and all this. But when you link food, and food journalists, their interest is more about the core food science and technology, and engineering journals, the core, people think this is not important enough. But from what I mentioned, so now you can see there is a gap. So I think it's up to all of us. We even had an idea of publishing a book, because a book there are a lot of books on food engineering, but nothing on humanitarian food engineering or humanitarian food science and technology, but finding people to volunteer. Oh, another thing I didn't mention, it was in my slide, but I didn't mention, another initiative we have is to develop a e-learning course. So rather than have a course now, the way I got involved, by the way, is Dominic Booney ran a course at the University of Lille and Ghent that was funded by the Belgian government to train NGOs and food scientists to everything that I talked about through case studies. And it was an excellent course over 2 years. And I was invited to be a reviewer. That's how I got involved, and I was so impressed. And with that led to our symposium. But we've thought, rather than having a course in a university, why can't we develop a course online and make it available for anyone free of charge anywhere in the world, and have animation and multimedia, etc. So FAO and WFP have some training courses, but we found it very difficult to get into their platforms. So then we had to do two things. We had to find a platform, and we're still trying to work, and Jose is involved in that project, to work with, use the FAO platform and put new material. But the other one is we need content. So Dominic Booney, my colleague from France, has developed a whole syllabus covering a lot of the topics in great detail, but we need people to write. We need volunteers to write about whether it's food engineering or food safety or whatever. But finding people to do this on a voluntary basis is very difficult.
We know.
So that project is not progressing as well as we would like to. But if you have funding, then it's easier to find people. But then you can get consultants and so on. But finding people to do things voluntary. Now, our group that I refer to, we are all volunteers. We are all doing this in our own time. And to be honest, we are struggling to write. Now, as I said, we had the intention of writing a book, but we just can't, myself included, can't find the time to start another project. That is why we are very keen to, that's why I'm appealing to those of you who are academics on this webinar, to get the new generation, the young people, more interested. Several times in my talk, I mentioned the importance of training and education, and including considering, and I will ask our academic colleagues to consider humanitarian aspects as a module in a humanitarian course, and teach them the social sciences. And if you live if you're in a university where they also teach humanitarian engineering, then you can go cross schools. That's exactly what's happening at UNSW, where we are teaching food science students humanitarian engineering by linking with the humanitarian engineering school. So I think that's a good start. Then this, and also to consider, that was one of my recommendations, and in the abstract too, for young food scientists and engineers, instead of thinking about the private sector as a career opportunity, to think about the humanitarians. And if they can get a job in a UN agency, it is not easy, but they, about 7 years ago, despite the fact that WFP distributes 90 million meals a year, they only had 4 food technologists in the whole organization, and no engineers. And then they changed a little bit because these are all driven by people who are experts in procurement, who are experts in logistics. But to give them credit, things have changed a bit. But in our opinion, more should be done. That is why we keep telling, that the role of food science and technology and engineering has to be recognized by food engineers as well as other stakeholders, governments, UN agencies and NGOs, and the private sector. The private sector, by the way, can see this as a commercial opportunity because all the food that I referred to has to be manufactured. And there are many European companies who manufacture. They won't do it for free. They won't do it for humanitarian purposes, but they have to satisfy the shareholders. But more and more, both for humanitarian reasons and for public relations, most multinationals are interested in getting into the humanitarian area. But some of the UN agencies and other NGOs and governments are not so keen for the private sector to be involved because they sometimes think, in my opinion, wrongly, there would be a conflict of interest. So more work should be done in that area too.
Very interesting, Jay. Thank you. Thank you again so much. I volunteer. If I'll contact you later.
No, please do. You are the type of that's the type of leadership we want, Virian. We want young, energetic, enthusiastic people like you to inspire other people. So if you do go to the IFT website that I refer to, you will see some case. So Donna is doing some good work through the international division. But you can get more involved in your region. So one of the things you should do is to reach out to Carla. So we can offline talk about it, and you can get your students involved. You may even be able to do a project through WFP.
That's what I'm thinking, because our new model that we have in our university, I think it suits with this. I think it can be aligned perfect. And that'll be an extra learning from our students, right? To get involved into these kind of projects. But anyway, I'll contact you later. And
very good.
We are interested. Okay.
Yeah.
Well, see, and if we don't have any further questions, I thank you very much again, Jay, for this exciting talk, and thank you all for participating. Keep tuned and check our website and Facebook page. We also have an Instagram account for further information about our next webinar, which will be soon during June. Again, Jay, thank you so much, and thank you everybody for being here.
Jay, I also want to say thank you. It was a wonderful morning. I'm glad that I was able to attend. Thank you, thank you, thank you.
Yeah, thank you everyone for attending and Viridian for inviting. So please, my last request is get involved, and there are many opportunities. So please get involved in whichever way you can. Thank you very much, and have a good day. Bye.